Hello friends, welcome to my channel. Let's have a look at problem 836, rectangle overlap. This problem is on the rectangular shapes, and we want to check if two axis aligned rectangles, rect1 and rect2, are having overlap or not, right? So if they have overlap, we're going to return true, otherwise we return false. So notice that here the positions of the two rectangles are very special. Their edges are parallel to the coordinate axes, right? So here are three examples. So in example 1, so we return true, right? So you can check actually this 1, 1 is inside this first rectangle, right? So here in example 2 and example 3, the return is false. So in this problem, two rectangles overlap means that the area of their intersection is strictly positive. So with that said, we are ready to do the analysis. Actually, this problem here is not hard. So the thing is that the method of analyzing the problem, once we know the method, actually writing the code is straightforward. So we are going to treat this problem similar as we did for problem 2446. So here the idea is the same. So we are going to fix one rectangle so that we have a reference, and then we can consider non-overlapping cases, right? So here let's do the following procedure. First, let's give a representation of the two rectangles. Let's see, rectangle 1 is x1, y1, x2, y2, and the rectangle 2 is a1, b1, and a2, b2. So we can assume that x1 is less than or equal to a1. In other words, the second rectangle is in the right of the first one. So if this is not holding, so we just need to switch rectangle 1 and rectangle 2, right? So below we will assume x1 is less than or equal to a1. Then relative to the first rectangular position, the non-overlapping cases are the following. First, the second rectangle is above rectangle 1. In other words, so b1 is larger than or equal to y2. So this is one case, right? So notice that b1 is the lower y coordinates for the lower edge, right? So b1 is larger than the upper edge, right? So this is case 1. Case 2 is that rectangle 2 is below rectangle 1. In other words, so the larger y coordinates, in other words, the larger edge coordinates in y, is below the smaller edge in y coordinates for the first rectangle. That is b2 less than or equal to y1. So the third case is that rectangle 2 is v right to rectangle 1. In this case, it corresponds to a1 is larger than or equal to x2. In other words, it's to the right of the rightmost edge, right? So the complement of the above three cases is the overlapping situation, right? So with that done, so if you can draw some pictures with a paper, then you can visualize all the three cases. Once we know the non-overlapping cases, so the complement will be the overlapping situation. So it's actually very straightforward to write the code. Let's just translate the idea and the procedure into code below. So first I'm going to check if rect1, the first coordinate, if it's larger than rect2 or 0. So if this is the case, I just need to switch this one, right? So this way we always have rectangle 2 is to the right of rectangle 1. Then let's first just for convenience, we just introduce some more variables. So though it's not necessary, so x1, y1, x2, y2 equals rect1, and a1, b1, a2, b2 equals rect2. And then, so let's consider the non-overlapping case. If b1 is greater than or equal to y2, or b2 less than or equal to y1, or a1 is greater than or equal to x2. So in this case, no overlapping, so we're going to return false. Otherwise, so we're going to return true. So that's the logic, right? So here the problem is not the coding, but the method to analyze the problem. So with that said, let's first do a check. Yeah, it passes the first example. Now let's look at generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for this video. Thank you.